everyone, my name is Hamza. Today we'll explore how adversarial machine learning and adversarial search are related. Both deal with competition and strategy, but in slightly different ways. Let's dive into their core concepts and connections. Adversarial machine learning. Adversarial machine learning examines vulnerabilities in machine learning models. The goal is to understand how certain inputs, called adversarial examples, can trick models into making incorrect predictions. This is critical because AI systems are increasingly used in sensitive areas like security and healthcare. Key concepts in adversarial machine learning. There are three main concepts here. Adversarial examples. These are inputs designed to trick the model, like an image slightly altered so that the model sees it differently. Adversarial attacks. These are methods that exploit weaknesses in the model to cause errors. Defenses. To protect against attacks, techniques like adversarial training, which teaches models to recognize these tricky inputs, and input sanitization, which cleans up the inputs. Adversarial attacks and defenses. We have evasion attacks. These happen when input data is modified during inference to fool the model, like changing pixels in an image. Poisoning attacks. Here, attackers inject harmful data during the model's training phase to corrupt its learning process. Defenses. Under defenses, we have adversarial training, which means exposing the model to adversarial examples so it can learn to handle them. Input sanitization is when inputs are cleaned before being processed by the model, removing anything suspicious. Game theoretic framework and metrics. Adversarial machine learning can be thought of as a game between an attacker who is trying to fool the model and a defender who is building the model to resist attacks. Metrics used to measure success in this game include robustness, how well the model holds up against attacks; transferability, how easily an attack on one model works on another; fool rate, the percentage of times the model gets tricked. Applications of adversarial machine learning. Adversarial machine learning is crucial in many fields. Security systems. Think about how attackers might try to bypass facial recognition systems. Autonomous vehicles. Robust models are needed to ensure safety when recognizing objects. Medical diagnostics. Errors in healthcare could be dangerous, so models need to be resistant to adversarial attacks. NLP, which is natural language processing. Adversarial attacks could trick systems that detect spam. Adversarial search overview. Adversarial search is all about competition between agents, often seen in games like chess. The goal is to plan ahead and anticipate the opponent's moves. Algorithms like min-max and expect min-max are used to calculate the best strategy by evaluating possible future actions. Adversarial machine learning and adversarial search. Although these fields are different, they have a lot in common. Both involve strategy and competition. Both can be understood using game theory. But adversarial search is about planning moves in advance in games, while adversarial machine learning is about defending models from deceptive inputs. Evaluation matrix comparison. Let's compare the metrics. Adversarial machine learning. We evaluate how robust the model is, how often it gets fooled, and how transferable the attacks are to the other models. Adversarial search. We look at optimal moves and the probabilities of winning based on each player's strategy. Practical examples. In practice, we have game playing AI. Adversarial machine learning and adversarial search can move together. Adversarial machine learning and adversarial search can come together, for example, in training AI for chess. Security systems. Adversarial attacks can target AI defenses in critical systems like fraud detection or facial recognition. In conclusion, therefore, adversarial machine learning and adversarial search both focus on strategies to deceive an opponent. Adversarial machine learning deals with protecting AI models from deceptive inputs, while adversarial search is about winning in competitive environments like games. Understanding both fields is essential for developing flexible AI systems. Thank you for watching and have a nice day.